So good morning. I think people will be streaming in for a while or puttering in a little at a time. We'll just ignore that. So my original talk today was going to be about the data web and a lot of sort of technical details of sort of using some of the inferencing on the semantic web and a whole story about metadata and data and sort of scaling kind of issues. But as I looked over the program from the last week and the talks being given this week, and as I talked to people who were here yesterday, it became clear to me that a lot of people had mentioned the semantic web, but no one had really talked about what it was sort of from a conceptual point of view about why do it. So there were plenty of talks, there's been lots of mentions of sort of here's what it looks like and here's the links, but so what? Right? The other thing is, it was very clear to me as I talked to people that no one realized that this thing has been an insanely successful technology, right? In fact, you're using it every day without being aware of it. So what I'm going to do today is walk you through sort of and trying to figure out how to do all this in 45 minutes. So I originally had about 300 slides. I've cut it down to enough that I can get through by throwing out a lot of the stories. So I had a story about search, a story about open data, a story about some other things. I'm really going to go primarily through the story of search, but many of the ideas are the same. Now, the other thing is I'm going to propose some challenges at the end, but this really isn't going to be a technical talk, so I'm not expecting people to, you're welcome to come up with questions at the end that are technical, but I'm also willing to take any questions about the semantic web. You've heard so much about it. I'm here, I've been with it since the beginning, so if I can answer your questions either during the questions answers after my talk, or I guess during the breaks or lunch or the discussion section tonight, I'm not hesitant to talk about this technology. I'm very fond of it. So, an early view of the semantic web. Some of you have probably seen this article. You may not recognize the cover because it's so old, but this was the semantic web article that Tim Berners-Lee, Ora Lassila, and I wrote back in 2000. According to Google Scholar, it's been cited about 18,000 times. It's actually 3 of my top 50 publications because Google can't figure out that those are all the same paper. But when we submitted the paper when we were talking to Scientific American, the editor asked us to give him a very brief summary of the paper. And this is what we sent him. So we kind of knew what would start the semantic web going. We kind of knew where we wanted to get to in the end. And then in the middle, we just had this words, then a miracle occurs, which is based on this very famous cartoon where you see 2 scientists pointing at a board full of things, and that's what it says in the middle, and one scientist says to another, I think you should be more explicit here in step 2, right? So we were just saying the same thing. You know, we sort of, if we build it right to start, it will grow and it will work at scale, which has really been the only way we've known how to make things work on the web. Now, Ora and I were a little nervous about this, but Tim said, well, you know, when I submitted to CERN, the very first proposal for the web, it looked a lot like this. There was sort of, you know, how we get started, what it looks like, and sort of some hand wave in the middle. So we said, okay, if it worked for the web, it'll work for the semantic web. Now remember, this was 15 years ago almost now. So the web was still a very big deal, but social web hadn't really started to come yet. Most people were starting to discover the new search engine called Google that had started about 2 years earlier. So again, the web was a very different place. Now, in the times that talk, I actually, since that article, I've given about 250 talks on this topic. What's interesting is, I was counting, in the past 2 years, I've given 4, right? And I was trying to figure out, was that because of the semantic web or was that because of me? And as I was getting my thoughts back together, I realized it's really because I kind of got bored of talking about it after all this, but also because it had transitioned into a form where a lot of the work that's going on now is based on the foundation that we put in place a long time ago, and there hasn't been as much innovation going on in the past few years as I'd like to see. So I'm going to push you a little bit today to see some of, you know, what's happened in the industrial space, What remains to go on in the academic space, and particularly for those of you who are students, maybe spawn some thoughts on where to go. This is my way of showing something that Petko showed yesterday, sort of a simplified version of what the semantic web is all about at the technical architecture. And this itself, of course, could lead into many, many more slides. But the critical thing to understand about the semantic web is that it's like the web. Okay, so on the web, if I have a document, I can have this statement in HTML that says this document points to another document. And I define the second document as a URI. If it's a web page, it's a URL, but it can also be a mail to address, it can be anything. So URI is the technical term for any one of those things that has sort of a few letters, a colon, and then some stuff after it. Most of the ones we use are called URLs, which are the HTTP colon or HTTPS colon that you're so used to. That's the hypertext transfer protocol. So that's the basic protocol of the web. Okay, and it's all about these links. Now, almost as soon as the web model was out there, so by the web was proposed in '89, around '90 was the first, Tim was given permission to start working on it. By '91, there was a package out, you know, he had his first demos, and it was released an open source version of what we would now call a web server. So it was called libwww, and it was a C package of setup. So you'd put this make file on your machine, you'd set the configurations right, you'd talk your sysadmin into trying this thing because none of them wanted to, and you'd say, no, no, you have to, I'm a professor, you have to do it, and then they would put it up, and then you'd be on the web. And you'd open up the browser, and sort of the first time I did this, the browser was sort of this homebrew someone had found somewhere. The second time we did it, it was Mosaic, and that was better. So Mosaic was the base of what became Netscape, which became Firefox, the first really popular browser. So all of that stuff was going on, and you would go to the web page, right? And I remember we sort of had a party when the web page hit 100 links. Okay, so this thing, you know, in 25 years has come very far. But the basic idea behind this thing, yeah. It was off. Maybe the glasses. But by 1991, there were already people talking about turning the web into a labeled graph. Right? Because we only had one kind of link in that upper diagram. So if I want to say, so what we now call a search engine, back then we were playing with some technologies, so there were some search-like things. And you would type in, Cook. And the system didn't know, am I looking for a person named Cook? Am I looking for the occupation Cook? Am I looking for something about cooking? So it really, even today, it's problematic to do some of that search 25 years later. But back then, people were saying, well, but what if you had a link called name? That would mean I'm talking about a person, or a link called product, meaning I'm talking about something you buy, right? So from the very first, there was an argument that we should have something like that. There was something called the MCF initiative that most of you have never heard of by someone named Guha, who will return into our conversation a little later. And Guha ran something at the World Wide Web Consortium, then a very, very young organization that was by about 95, 96, and they proposed 9 different link types. Okay, and other people said, no, we want more, we want less. Well, one of the things that happened was a discussion where people started saying, what we really want is an infinite number of links. But we want an infinite number of links in some kind of naming space where we can understand what the links are doing. Okay? And we all realized we already had one of those. It was exactly the same URI scheme we were using for these two sides of the links. So essentially, when you see http://ucom.ca/computer science/something, what you realize is that first part, the server part, tells you who owns that thing. And the next thing, although there's no standardization, tends to fall into something that says, this is what it's about. So I can't pretend to be a UCOM server. in any easy way. I can play with the things in my space. So now what can happen is Jacqueline and I can decide we want to have some special web links that we will use to label things about a project we're doing. And if we put them in a space we control, nobody else can accidentally be confusing the words the way we could in English. So if we just labeled them cook, what would that mean? But if we labeled them http:// et cetera, et cetera, et cetera, et cetera, cook, right? Then it's only the one we defined it as, and anyone who's using it should know what we meant by it because we're telling them who owns it. So that's kind of the social agreement of the web is in that naming. Well, the social agreement of the semantic web would be in that same naming. So that's where it started. And the RDF model simply said, we'll turn the web into a set of triples, a resource, a link, and a resource, and we'll name the links using exactly the same naming scheme that we use for the web. Well, pretty quick, some of us started realizing, this is now about 96, 97, that if we were going to do that, why don't we, since we're using a URI, why don't we put something meaningful at that URI? So when you type a URI into your browser goes and gets a document. So the thinking was, why don't we have a document there that will tell you what the terms mean? And there was some fighting over, should it be in English? Should it be in a machine language? What machine language should it be in? So there were a lot of explorations going on in the time. My group at the University of Maryland came out with the first language that really started to get used in the academic space. It was called SHU, the Simple HTML Ontology Extensions. It came about because I said to one of my students, you know, we need a lot of stuff to put into a knowledge project we're doing. Right back then, big data was to have like 10,000 or 100,000 links in your graph. And I said, you know, we got this new web thing. Like there's all these computer science departments. Let's go out and just scrape those, and we'll have all the professors and their courses and things like that, and we'll stick that in our system and we'll use that to test scaling. And he came back to me a couple months later and said, you know, you can't do that. They're all different. They all look the same, sort of. Somewhere on the page it says faculty, and you click on the faculty and you get a set of names, and you click on a name and you got stuff about that person. But when you actually drill down on it, they all look different. Every school, every department, things like that. There was no standards. So we started saying, well, you know, so could we get humans to give us some clues? So why don't we give them something that they would tag on their page that this is the faculty? Right? And so the semantic web grew out of this idea of let's have vocabularies of tags defined in these URIs. So now what happens is if you have a document that describes a person, we could say, this guy is a professor as defined at the jobs website. Right? So this is just a shortcut for http:// something that ends in the word jobs. Right? And this would be our website. So we'd say, well, we're going to use something called a title, et cetera, et cetera. So now Jobs has something called the place of work, and I have my web page. So now that little thing up at the top says, I'm looking at a person named Hendler whose title is a professor and whose place of work is this university. Okay? But notice that I'm not saying that in English. I'm using these unambiguous phrases. So if someone else said place of work, right, but didn't use jobs, place of work, something else, place of work, something would have to say they're the same. They wouldn't be automatically assumed to be the same unless they were exactly string equal, right, go to the exact same place on the web. Of course, the next thing we started doing was figuring out how to extend the system. SHU added some simple rules. The RDF language came along, didn't have that. There were some fights. Eventually, we ended up with a project called DAML, the DARPA Agent Markup Language, which was funded at DARPA, and I was the person who gave out the money. And when you have millions of dollars to give to academics, if they'll come play, they're really happy to come work with you. So I gave lots of money to lots of people in the United States to come work. Then I called a couple friends in Europe and said, let's do something very subversive, because on the web it doesn't make sense to fight. You guys say the US is going to do it, and I'll say Europe's going to do it, and both of our governments will give us money to make sure the other guy doesn't do it first. So we did that. And the EU got a lot of money to do it. In fact, frustratingly for me, by the time I left DARPA, the EU had all the money. The US stopped giving out. So I was the only guy in the world who didn't have any funding for the semantic web, because I wasn't allowed to have US funding since I had been the funder, and I wasn't allowed to have the EU funding because I lived in the US. Long story. I did okay. So the DAML language went through a standardization process, came out as the web ontology language OWL. Do you have time? Yeah, sure. I'm going to run out of time by the end of the talk, but that's okay, I always do. But I like adding those little anecdotes. So there was obviously a problem because people were saying, no, if it's the web ontology language, WOL, right, is what we should call it. We're like, no, we want to call it OWL, but the ontology web language sounds crummy. And Dave DeRoer, who a few of you know now at Oxford, came up with the most brilliant thing. He walked into the room one day with a copy of Winnie the Pooh and showed us a picture. And it said, Owl was the smartest the smartest creature in the forest. He could spell his name right, and something like, could spell Wednesday such that you knew it wasn't Thursday or something like that. But there's Owl sitting next to a little sign that says WOL. So if you go to the official FAQ from the original OWL language, you will see that there's that picture with permission of the publisher to define why it looks like WOL but is pronounced OWL. So it's called the Web Ontology Language OWL. So if you're trying to find the acronym, that's it. Just call it OWL and live with it. Okay, so the idea was now what we're adding in OWL, we added a lot of stuff, and that's going to be something I'm going to talk about in a few minutes. But the first thing we really wanted in OWL was a way to say two things were the same. So we wanted to say, okay, so I've been defined here on my web page in that thing I just showed you before, and someone else somewhere else. So when Wikipedia had come along by then, and people were creating something called DBpedia, which is sort of a data dump of Wikipedia. Okay, and now DBpedia is sort of the center of the linked data cloud, which I'll say a little bit about in a couple minutes. So DBpedia has me listed this way and says I'm a computer scientist. And my site was listed this way and said I'm a professor. So now, if you put this all together, you could realize that this person is the same as this person, and he's a professor of computer science. So now you can start doing some things that you can see where it becomes valuable. In fact, over the years, started putting a lot of those in. So this is about 2 years ago. If you pulled me up in the, this was one of the various search engines around. So this was the first 44 of, I think, 900 links that all are describing me in some way or another. So the same as is have been asserted between all of these things. So this first chunk here is all these papers that I've published that are in the Southampton ePrints directory that I think was mentioned in Wendy's talk. It has a semantic web representation, and it says this is the same person as this, which is actually pretty important because if you have two authors with the same name, which happens an awful lot when you have particularly Oriental names. So you go to DBLP, the big database server, or you go to Google Scholar, and you have a problem because, so one of my colleagues is named Peter Fox. There are about 100 Peter Foxes who are scientists who publish. So how do I find his papers, right? And again, on the semantic web, you can say it's this particular Peter Fox, and now you want a way to start tying those things together, okay? Here's the one where the World Cup's over, but if we were here last week, this would have been great. It was, so what in US shows up as this thing called a soccer player, these are things that show up in other languages that are related, things like that, countries, towns. So again, you get multiple languages and things like that. So you get this mess of links. And of course, very early on, and I've already been using the term ontology, you get this idea that there's some ontologies and that they help you organize things. Now, around 2002, at a famous talk, this slide was presented based on a slide that Deborah McGinnis had put together earlier in 1999, talking about what an ontology is. And the idea is that you can start with sort of a catalog and you add more and more knowledge representation. You get denser and denser in sort of meaning. So here you're just saying, this thing's one of these, but it doesn't really mean anything. And here you have formally, if this is a member of this class, then it must have this property, things like that. Right, so this has been a view of ontology that's been out there for a very long time. This is opinion about that view of ontology. And now that Deb and I work closely together, she really, really hates it when I show this slide, because that was her most famous slide, and this is becoming mine. But the question is that the right view? Is expressivity what this ontology stuff is all about? So around 2006, I think it was, 2007, I gave a talk called The Fellowship of the Semantic Web, the Two Towers, right? And this was the tower I talked about, right? Which was ontology, and this is sort of the OWL description logic views. So you can ask me later how description logic got into all of this. It needed a formalization, and that's kind of where it came from because of politics as much as anything else. But remember the story of Lord of the Rings, right? The big guy up in the eye, Sauron, is the most powerful wizard in the universe, and he's put a whole bunch of his power into a little ring, and that ring will let the whole world be ruled by Sauron, so there's tremendous power. But there's a problem, you know, this whole thing has to be patrolled by orcs, because if this one little guy comes in and manages to throw the ring into the lava, then the whole thing is over. Well, we don't have orcs and things, but we actually have an extremely powerful ontology that's based on a decidable logic, description logic basis, a decidable logic basis. But if an inconsistency sneaks in, the whole thing collapses. Right? So the question is, how do you keep an open system that all sorts of people in the world want to play with consistent? Right? On the other hand, there's a lot of power. This is just one example. Okay, so one of the things used to say why you need this is, let's say you're trying to do inference with a reasoner, you want it to be sound and complete. And here's what was sort of the most used example early on was pharmaceutical companies. Right? So a pharmaceutical company gets all of this chemical stuff. They run what's called combinatorial chemicals. So you compare sort of every chemical to everything you might treat with it. So here's all the germs I know about, and here's all the chemicals I know, and I try them 1,000 by 1,000. I get this 1,000 by 1,000 matrix of which things have what kind of reactivity. And then I want to try to explain what's going on for any of them where it looks like a good thing. So you build these very deep representations, you use this reasoning mechanism, and you can set something like, well, since this thing is hydrophilic, antibiotic, et cetera, it falls into this class, and the things in this class are known to react with the things in that class, et cetera. And a lot of this work still goes on to this day, and there's a lot of different ways people are doing this now, trying to say, how do we build an open system? Because when you read bio papers, they don't all agree with each other. But you want to try to, if you're trying to, say, cure cancer, you really want to look at, you know, all these different cancer models and say which papers agree, which papers disagree, which papers line up. So we have a project going on to do that to this very day, looking at how do we take all these different pieces of those publications and put them together and tie them to models. But now you have to add these things agree, these things disagree, but you're still trying to keep a consistent view, right? So if you use this thing, drug companies generally test, I forget the number, but it's a few hundred drugs maximum per year. Of those, only 3 or 4 will go to clinical trials, and you need one of those to succeed, and you become a very big, famous drug company. And if they all fail, you go broke, right? And so all these pharma companies spend a lot of their time going through which are the most promising drugs. So now you have something that can sort of categorize it, and it's worth millions of dollars to you to get it right. So the return on investment of these big ontologies was really systems where you can put a lot of money into the design because there's a lot of payoff. But it's a lot of work to build these things big and consistently and to maintain them, et cetera. And this was sort of the knowledge representation view, grew originally out of expert systems and things like that, that was powering a lot of the early semantic web. Okay, so the problem with this one is when you want to open it up on the web and when you want to have a lower effort thing, right, that won't work. So the mantra sort of those of us who were in the other camp, which I'll get to in a minute, was you know, on the web, what we had learned by the web browsers, there had been all these beautiful ebooks between about 19 79 and 1990, there were all these hypertext systems, and they were beautiful. They made what came out as the web look like crap, but they cost $1 million each, right? And there's not that many people who have $1 million to put onto putting something on a non-existent web. But when the cost came down to almost zero, lots of people started to put things on it, and then the browser started to get popular, and all these students who were told, put your physics stuff on the web, put a little bit of physics stuff, and then they put pictures of their... One of my students had the most popular website in the world for a couple months. It was a roller coaster website. Got 100 hits the first month. Right. Those of you who know anything about the web know that's about 2 seconds of a bad page now. Just browsers alone will give you about 100 hits a second, minute, depending where you are. Okay, so again, very different orders of magnitude, but you know, he was not funded to put up a roller coaster page. That's just what everyone wanted to look at. He was funded to put up the computer science page. So what happened is a lot of this stuff started to grow. So a linked data view started to grow. The first time I spelled ontology, I had a big O. Now I have a small o there, right? So I'm calling these small o ontologies. And this is kind of the other tower I talked about. This is a tower called the Tower of Babel. Some of you may have read about it. So according to the Bible, a bunch of people said, we'll build a tower that will reach the sky. And essentially, the people pushing this view said, you know, we don't really need all that ontology stuff. We just need a little bit, right? And who cares if we all speak different languages? Well, the problem is if you all speak different languages, this is what happened to that tower. This is, some of you have read the Bible. Genesis says, what happens is God says, hey, these guys are going to build a tower. How can I make them stop building the tower? I know, I'll make the peoples of the world speak different languages. And they won't be able to cooperatively build this tower. And sure enough, they couldn't build the tower, and they all went and formed their own nations and started fighting with each other and stuff. So the way the tower was brought down. So this view said, you know, we will just have lots of stuff. Data view said, well, let's at least start having these different languages and putting in some terms together. So I can communicate with somebody French in a context with only a few words if we can point at things and sort of things. So I have no idea what this is called in French. But if I walk into one of the coffee places around here and I do this, they'll probably figure out what I want to drink, or at least they'll show me a couple of options. And so we can communicate by having shared reference. So that same as stuff. And this thing became known as the Linked Open Data Cloud. You can go to something called linkdata.org. Not well maintained anymore. Now, one of the problems is people started thinking this was all the linked data. What this was all the open linked data that a bunch of academics made available from their experimental projects, mostly funded by the EU. And then this group over here became governments, and it was, again, mostly governments releasing data and some second party making that into linked data. Okay, so this thing grew very well, but really wasn't the main story of what was going on in terms of acceptance of the semantic web. So if you went to sort of academic conferences, you would watch this grow, and everyone would talk about how it doubled every year, things like that. And then a couple of years ago, it sort of started trailing off. And that wasn't because the thing got unpopular. The reason it started trailing off was it went somewhere else. Okay? So was this stuff happening in the real world? Well, you may have heard of some of these companies. Okay, so this is Facebook, right? Facebook's a social graph company. Anyone here have a Facebook account? A few people? Yeah, one is billion people have this. Facebook, you can get a large chunk of the information Facebook is available to you in the linked data formats, and Facebook actually pushes something called the Open Graph Protocol, which is built on top of these formats. Because Facebook wants a big graph of information linking things together. Okay, Oracle in 2012, the standard Oracle load, you can no longer get the main Oracle thing without the semantic extensions, which are basically an RDF and a little bit of OWL stuff. Okay, the big winner though was Google, okay, and what they call the knowledge graph. So when I said a lot of you are using this stuff and don't realize it, whenever you do a Google search and you see that little box at the side, or Bing or any of the other major search engines, the stuff here is coming from a graph being maintained as a graph of triples. Now, they're not actually using, there's some argument over whether they're internally using the standards. The answer is no. But what you put on your website is actually in a format based on semantic web representation, something called schema.org I'll talk about in a minute. Okay, and that's what powers this knowledge graph. And in fact, in the past year, Google has hired a lot of people, including Natasha Noy, who was one of the very famous ontologists. It was just announced this week that Chris Welty, who was one of the people behind IBM's Watson and who was a well-known semantic web person, is going to Google. I think he starts either this week or next week. So again, Google, for years I couldn't put a student into Google because they said, we don't want semantic web students. So my students would end up there because they did security, or because they did search, or because they did something else. I have about 4 former students at Google. This year, one of my students was hired by Google explicitly because she knew semantic web and they needed somebody who could help build out the knowledge base in the area of business and finance. Okay, so they're really committed to that, and I'll talk about that change in a minute. So what's been driving this change is really sort of 3 things. Embedded markup, so an ability to start putting this stuff on. And the one that's really one is something called schema.org that I'll talk about in a minute. Sparkle is the query language for this stuff. It turns out, you know, I was at a meeting recently of some of the top supercomputing people. I was on a study by the Secretary of Energy of the US as to whether we should build the next generation of exascale computers, i.e. was it worth a couple $1 billion to build another set of supercomputers? And I was just stunned there because a lot of these guys kept saying things like, you know, we want to go to graph databases and we love this Sparkle language. And I went up to some of them after and said, oh, I'm so glad to hear you're using Sparkle. You know, I was involved in Sparkle and RDF. They said, oh, we hate RDF, but we love Sparkle. Right? Well, what they mean is we needed a graph query. A standardized query language for graphs, and Sparkle was a great standardized query language for graphs, and it's even more powerful than a lot of them need because it has the labeled graphs, and a lot of them are using either simple labeled graphs or unlabeled graphs, so it fits very neatly in the thing and lets you specify Sparkle queries. So that's been growing. So for example, you can go to the British Museum Sparkle endpoint, the BBC Sparkle endpoint, the US Library of Congress Sparkle endpoint. I'm sure there are some around Canada. Canada has an open data site that has lots of academics have put pieces of it into the RDF stuff. And the other thing that has been going on in that is all of these things come with a little bit of organization, what we call a lightweight knowledge. Okay, and so some of you have heard this expression, a little semantics goes a long way. This is something that I am sometimes credited with having created because I did. Although there's a web page down here, and if you go to this, or if you just search on little semantics, that site will come up. Tells the whole story. Because me and another guy both started using the phrase around the same time in different contexts. We both claimed we learned it from the same guy, but when he asked him, he swore he never said it. So we're really not sure where it came from. But we put it on a t-shirt. Right? So it was on our shirts in 1997. So that's why I get to say I was there first. But anyway, a lot of data, a little semantics. And because finding anything in the web is hard, anything more complicated than a standard keyword search was going to require some of this stuff. So we said a little semantics could go a long way. Around 2010, people started talking about a generation of semantic search. This is, I'm only using my article here because it says it in big letters and I didn't have someone else's article to point at. And there was, by 2010, 2011, a lot of companies competing for this space. Now, what's interesting is if I went through this with you, which I won't in the interest of time, some of these companies have gone out of business. Some of them have been acquired. So the 2 biggies on here is, there should be something called PowerSet here. Well, Freebase was acquired by Google to build their knowledge base. I think Siri was, you've heard of Siri. Apple bought it. Apple bought it, took out all references to the semantic web, made it talk only internally using non-semantic web stuff, and they use semantic web primarily for external access. So they use it as a standard for talking to Yelp, which, by the way, you can get in RDF, talking to Wolfram Alpha, talking to Freebase, and one other, I forget. So in other words, a lot of people said, you know, the scalability of this stuff in its native form may not be what we want. We don't want all those URIs and things. But boy, when we want to get something from someone else or give something to someone else, having a standard is important. Somewhere on here it should be PowerBase, but I think this, PowerSet, there they are right here. So PowerSet got bought up by a company called Microsoft, got renamed Bing. Right? So again, so there are some big winners on here and lots of losers. Okay? And the big winner in this to date now is a company you've heard of called Google. Here's the story of semantic web at Google told in a set of quick clips. Okay, so 2009, I was at the Google Faculty Summit the last time they invited me because I made some noise about them being wrong. And they don't like people making noise about them being wrong at the Google Faculty Summit. This was what they were presenting. Peter Norvig was presenting a paper that later got published as The Unreasonable Effectiveness of Data. There's a history of that name. But basically, these are the two, you know, kind of big bullets that were in that article. And you can go find the article. But they were saying, for many tasks, words and word combinations provide all the representational machinery we need to learn from text. Choose a representation that can use unsupervised learning or unlabeled data because that's a lot more plentiful than labeled data. So Google's claim was, we don't need enough people. We're just going to build this stuff out of learning, right? And they were very successful at that. But anyone who knows about the web, think about it, right? You have this long tail of information. So Google's top subjects get millions and millions of hits a minute. Right, at the time that 2009, when this came out, I believe the #1 search was Britney Spears. And Britney's page, you know, I mean, again, Google could find anything you wanted about Britney Spears just based on the behavior of people. But some obscure rock musician in Montreal, who they heard about once a year, somebody would Google for that. So at any given moment in Google, they say about 18, it used to be 20% of the searches coming in are searches they've never seen before, right? So they're constantly trying to deal with new information, okay? And you can't do a lot of learning on stuff that you don't have a seed of. So so for a long time they were pushing this. But 2012, Peter Norvig was giving talks where he would be asked about semantic web, and his answer was sort of this kind of hesitant answer. So he said, semantic web is coming along, but it's not quite there yet. There's some markup on the web that's explicit and is great when we find that, but mostly we still have to do that other stuff. Okay? A year later, remember Guha? We mentioned Guha back in the 1990 context. Well, Guha was one of the founders of RDF. Felt the language had got too complex for webmasters to use. Wanted to reorganize it. Was at a few different companies. Was at Psych for a while, et cetera. Finally ended up back at Google where he said, let's do this right. And he came out with something called schema.org. Okay, schema.org is a way of embedding a small little vocabulary about things into your website. I'll talk more about it in a second. So he said, a lot of the pages on the web are generated from structured databases, and the semantic web has had to win and had to get the webmasters to be able to make those generated databases contain the semantic information. So you had to convince the webmasters. You had to give them something they could use. And none of these guys are going to have gone and gotten, degrees, PhDs in knowledge representation from top universities, because if they got PhDs in knowledge representation from top universities, they don't have to work as a webmaster. They can go work at a web company and put advertising on people's pages and never do knowledge representation again. Sorry, that's a critical comment. So they came out with this thing called schema.org. Now let's see. No, it's not what I want. Let's see if this works. Nope. Okay. I have to do it the other way. Okay. I'm not going to go through this, but basically what schema.org is Google created. It's actually Google, Microsoft, Yahoo, and some small web companies. So it's a consortium. Google really calls the shots just because they're bigger than all the other guys. And Guha is sort of at the top of the pyramid. But what they did is they just created a bunch of simple actions, simple facts, things like that. So you can scroll through this. There were 240 of them when they came out, and there's a mechanism for extending it locally. And then to get a new thing accepted is very, very complicated. You have to show it. Since their inception, I think there are about 6 things that have been added: genealogy stuff, data set stuff, and a few others. I was lucky enough to have been involved in getting the data stuff put on there, and it wasn't easy. We had to get letters from governments around the world saying, we promise to use this markup. You have to convince Google that there'll be millions of pages with this stuff on it before they'll put it into the supported thing. But anybody could extend this. You can all do your own, and Google has mechanisms to let you play with it. So we have movies, and if you have a movie, so these are the properties that one of these things has, and if you click on it, you get this hierarchical thing. So since a movie is a creative work, it gets, so these are the things a movie has that are specific to movie, and then it gets all these things because it's a creative work, and all creative work have those things. And then creative works are things, so you get it from that, etc. So I'm not going to click on these. We could see it. So basically, there were 3 formats from this. So this is how you used to put information about the movie Pirates of the Caribbean. If you put it in the microdata form, it would look like this. The RDFA is the one that actually is. Yeah. So you make it look like this. And now what you're saying is, we're talking about a specific movie, and this is the name of the movie, and here's a description of who's director, et cetera, et cetera. So now what happens is when Google comes to this page, okay, on this page, they have to guess who the director is and try to learn that. Again, it might be easy if it says this, but if that's in text somewhere that says the director of this movie is so-and-so, they're not going to get it, right? So they've got these different formats. In fact, more recently, because app designers say, we don't want that stinking web stuff, we want JSON. You know, give us JSON or get out of our way. So there's something called JSON linked data, and that's actually now starting to be probably the most used form of linked data. And what it is it looks like JSON, so you can parse it, but a system that wants it in a declarative form, you can parse that right back into RDFA, et cetera, and mix it into your data sets. So anyway, so Google makes great use of that stuff. In fact, last year at the World Wide Web Conference, Google gave a keynote. Guha gave a keynote at one of the workshops. Said 20% of the Google crawl now has this stuff on it. Okay, so when you want to know, has the semantic web in some form been successful? 20%, 5 million web domains is the number he used, including most of the top domains. Right, and that's been validated by some other experiments which have found numbers between, so Creative Crawl looked at whether they could find this stuff, and they don't crawl some of the big sites, they crawl some of the smaller sites. They found it on something like 10% of the stuff they crawled. Bing had an experiment where they found it on about 15%, but we're talking about very large number of pages. Now, back when I started this DAML stuff, there was someone who's now very well known from Google in the audience, who remain anonymous, who said, you know, this RDF stuff is fine and good, and we know a couple companies are starting to fool around with it, so this is 2001, but we're never going to see it as a percentage of our crawl. It's going to be at the 0.000 thing forever. Okay, so I can declare victory and go home, but I don't want to, right? What motivated them to move to this schema.org stuff? Why wasn't the learning enough? Well, it turns out that when you look at search, a lot of what search is nowadays is people who are looking for information about a thing, a particular thing, this guy, this movie, this event, right? They call these entity searches. And that's about half of the searches on the web. And entity searches like to get this kind of summary. So the thing that shows up in these knowledge boxes. So now Bing, Yahoo, so all the search engines will now give you these knowledge boxes in various ways. Okay? But here, so from a talk that Peter Mika gave in 2014 at a search conference, here's a few of the examples he gave of why they want humans to help mark up their sites. Right? Why, when they do it just by learning, they get in trouble. Right? So here's a good one. So Vin Diesel, who some of you know is an actor, Vin is alive and well, but his knowledge graph said he died January 30th, 2014, and that the location where he died would be announced eventually. Right? So we don't know where he died, but we think he's dead. Right? Wrong. Okay? Well, that's a simple factual error, so you can imagine where that came from. How about this one? Ice cube is a product category. An ice cube is a small cube-shaped piece of ice By the way, Ice Cube is 5'7", married to Kimberly. Okay. Obviously, we're confusing a couple Ice Cubes. Or I got to show you my all-time favorite. Okay, Michelangelo. All of this information is exactly correct, but the Ninja Turtle may or may not be exactly the Michelangelo you were looking for. So they actually have people involved in cleaning up this stuff, but when they get it from schema.org, somebody reputable, the webmaster of that site has already done it for them, right? Facebook, I could tell the same story about their thing called OGP. Here's some of the other companies that use the semantic web technology regularly in their systems. And if you click on sorry, whoops. There was a PowerPoint in here somewhere. These aren't live links because there's a picture from Peter's talk, but you can find his talk on the, actually no, this is from a Quora answer and you can go find it. But again, any of these things will take you to places where you can see it. So on eBay, if I clicked on this headphones, you'd see that there's a semantic description of the headphones being set on eBay. So eBay has a machine-readable description of every single item. They build a big catalog of this and they publish out some of that so that other people who want to say what you can get on eBay. So for example, when you go to Google and says, hey, that thing you want to buy is on eBay, that's how Google gets the information. Okay, so. No. Okay, so now let me finish up by saying what's interesting to me now. Okay, so remember where we started. We started with this idea that knowledge could be useful. I've shown you that bottom of the semantic web, that little bit of knowledge stuff, has been very, very successful. But what about all that other stuff? Those of you who are doing PhDs, mostly, if you want to do a PhD in sort of current semantic web, you sort of have two choices. Take the stuff going on the formal side of the semantic web and extend it a little bit, using OWL kind of as it is with a little bit of mucking around, or become like a database guy and extend RDF and RDFS with scalability, right? And there's really this big gap in the middle, which is sort of where the semantic web really has always wanted to live, which is lots of vocabularies linked together describing lots of things. But one of the problems is that's a very hard place to play academically. So bridging the gap between this linked data view and this ontology view has some research challenges, and this is where we really need still to get some work done, because description logic and various first-order logics, and even when you extend these to probabilistic logics, fuzzy logics, etc., they're useful formalisms for KR&R, but they're really not addressing the needs of the web, which is knowing who said what, in what context, how did they say it. So it's not just 80% of the time cook means is somebody's occupation, and 20% of the time it's some person. It's really saying this particular website is talking about a person named Diane Cook, and this particular website will sell you cooking tools, right? Empirical comparisons are great in scaling systems. So my students who end up at Google nowadays are mostly the ones who develop parallel algorithms for getting graph searches better in the knowledge graph. But that's not really what we want to do. That's not all we want to do as academics, right? Petko gave this great talk yesterday about all this stuff we could do if we could harness more of the ontology stuff. But the problem is the knowledge representation of the ontology world doesn't really fit the web world. So a sufficient formalism for semantic web applications in academia really wants a model that's going to account for this linked data. So there's no database calculus equivalent for Sparkle. And it needs to provide a means for evaluating incomplete reasoners. So right now, when you go out with a search engine in the semantic search, how do you know if you found anything useful or not? How can you report that Michelangelo thing was wrong? You can use the F metrics that are used in natural language, but they don't tend to get you the right answers, because it's hard to get precision and recall numbers for these really huge text sets or for pieces of things. So again, did that one with all the information right but the picture wrong, how would you score that in something that was trying to say whether it was a good result or not? Okay. The second thing is a sufficient formalism for semantic web applications. So this is for representation and applications. What I believe is we really need to move away from this notion that there's something called an ontology. We really need to move this to this notion that there are a lot of different kinds of ontologies that have different roles. And if we're going to describe them on the web, we need to talk about what we used to call in the formal language external reference. Now we need to really talk about that linking. So we got to bring in the linked data story. And we have to stop talking about sort of formal ontology alignment as the only thing, because in a lot of these systems, in schema.org, all you get is a partial match. So it says, for these parts of the creative thing, we can put them together, but what about everything else? And then how will we bring this non-expressive formalism together? So, to summarize, the semantic web, whether it's linked data or vocabularies, is really getting a lot of use in many largest websites. So I hope I've convinced you of that, right? So if anyone ever asks you, when are we going to see the semantic web? Your answer is 2011, okay? Or when will you see it commonly on the web? 2013. We're past that. It's there. It's in Google. We won, okay? But there's a lot more work to do, both in improving semantics for applications. I didn't talk about this today, but one of the things that's really problematic, if you go to these sort of small semantic web companies, hundreds of startups, and no one has quite found the model that wins. Google sucked it into search and is winning in that space. But what are all the other things we could do with semantic? What's the business model for this? And there's a lot of companies competing to try to win. And then academic research in this area is really exciting, but currently a lot of people are just extending the current formalization or faster queries. And I hope what I've convinced you today is there are some big problems, some really cool questions that still remain. Thank you.